My name is Shubsina and welcome to my channel. So today we will learn about the DS queue. In the previous lecture we have seen about the stack. So today we will learn about the DS queue and its types. So let's begin. So first of all, what is a queue? A queue can be defined as an ordered list which enables insert operations to be performed at one end called clear and delete operations to be performed at another end called from. Queue is referred to be as first in first out list. For example, people waiting in line for a rail ticket from a queue. It is a real world example, right? So this one is the rear, which means in the end queue insertion occurs, and this is the decrement, means deletion occurs. So let me come to the applications of queue. So we all know that due to the fact that queue performs actions on first in first out basis, which is quite fair for the ordering of actions, there are various applications of queues discussed as below. Queues are widely used as waiting list for a single shared resource like printer, disk, CPU. Queues are used in asynchronous transfer of data, where data is not being transferred at the same rate between two processes. For example, pipes, file, I/O, sockets, etc. Third point is queues are used as buffers in most of the applications like MP3 media player, CD player, etc. Queues are used to maintain the playlist in media players in order to add and remove the songs from the playlist. Queues are also used in operating system for handling the interrupts. So let me come to the complexity part. So when we see about the complexity, there are two cases, the average and worst. And in case of space complexity, the worst case. So in case of axis, theta n is a time complexity in average case. In case of search, theta n is also the time complexity in case of average. The insertion will be theta 1 and the deletion will be also theta 1. These are all the four time complexity in case of average. And in worst case, the axis will be O of n, the search will be O of n, the insertion will be O of 1 and the deletion will be O of 1. So you guys can pick out the similarity that whenever in here theta n and theta 1 will be occur, there are one pair of theta n and theta 1 each in case of axis and insertion, deletion and search. So in worst case also same situation will be occur, but in case of theta here will be O. So you guys can keep that in mind. And in case of space complexity, the worst case will be O of n. So now the types of queue. So basically before types of queue we will see that we should discuss the queue in a more brief manner. So let me explain that. Let me tell you a introduction and a real world example so that you can understand the queue first. Then we will come to the types of queue. So what is a queue then? Queue is the data structure that is similar to the queue in the real world. A queue is a data structure in which whatever comes first will go out first, and it follows the FIFO, first in first out policy. Queue can also be defined as the list or collection in which the insertion is done from one end, known as the rear end or the tail of the queue, whereas the deletion is done from another end, known as front end or the head of the queue. So the real world example of a queue is the ticket queue outside a cinema hall, where we know that the person who enters first in the queue gets the ticket first obviously, and the last person enters in the queue gets the ticket at last. So similar approach is also followed in the queue in data structure. So now coming to the types of queue, there are four different types of queue that are listed in the diagram. First is simple queue or linear queue, then circular queue, priority queue, and finally the double-ended queue, or we also call the double-ended queue as DQ. So let's discuss each of these type of queue. So first one is simple queue or linear queue. In linear queue, an insertion takes place from one end, while the deletion occurs from another end. The end at which the insertion takes place is known as the rear end, and the end at which the deletion takes place is known as the front end. It strictly follows the FIFO rule. So as we can see in the diagram, that in here the first value will be the DQ, this front end, and deletion will be occurs, and the fourth end will be NQ, real insertion. That one in case of a real world example, one person will be going inside this queue, and from the front end each person will be get out from the queue. So in this way delete and insertion occurs in case of simple queue or linear queue. But we should keep in mind that there is a major drawback of using a linear queue, which is that insertion is done only from the rear end. If the first three elements are deleted from the queue, we cannot insert more elements, even though the space is available in a linear queue. In this case, the linear queue shows the overflow condition as the rear is pointing to the last element of the queue. Then, circular queue. In circular queue, all the nodes are represented as circular. It is similar to the linear queue, except that the last element of the queue is connected to the first element. It is also known as ring buffer. You can see that here it will be in a circular way. So why does it call the ring buffer? Because all the ends are connected to another end, right? You can see this is connected to one end and that is connected to another end, right? So the representation of the circular queue is shown in this image. Again, the major drawback that occurs in a linear queue is overcome by using a circular queue. If the empty space is available in a circular queue, the new element can be added in an empty space by simply incrementing the value of rear. The main advantage of using the circular queue is better memory utilization. Then comes the priority queue. It is a special type of queue in which the elements are arranged based on the priority. It is a special type of queue data structure in which every element has a priority associated with it. Suppose some elements occur with the same priority. They will be arranged according to the FIFO principle. The representation of priority queue is shown in the below image. That element with the highest priority will be deleted, right? So what does it mean? That the highest priority with the element which has the highest priority will be arranged according to the FIFO principle. So as we can see in the diagram, that insertion in priority queue takes place based on the arrival, while deletion in the priority queue occurs based on the priority. So priority queue is mainly used to implement the CPU scheduling algorithms. So there are mainly two types of priority queue. First is ascending priority queue, second is descending priority queue. So what is ascending priority queue? In ascending priority queue, elements can be inserted in arbitrary order, but only smallest can be deleted first. Suppose an array with elements 7, 5 and 3 in the same order, so insertion can be done with the same sequence, but the order of the deleting the elements is 3, 5, 7. Then comes the descending priority queue. In descending priority queue, elements can be inserted in arbitrary order, but only the largest element can be deleted first. Suppose an array with elements 7, 3 and 5 in the same order, so insertion can be done with the same sequence. but the order of deleting the elements is 753. So it comes to the DQ part. So what does DQ mean? Or double-ended queue? In DQ or double-ended queue, insertion and deletion can be done from both ends of the queue, either from the front or rear. It means that we can insert and delete elements from both front and rear ends of the queue. DQ can be used as a palindrome checker, means that if we read the string both ends, then the string would be the same. DQ can be used both as stack and queue, as it allows the insertion and deletion operations on both ends. DQ can be considered as stack because stack follows the LIFO, last come first served principle, in which insertion and deletion both can be performed only from one end. And in DQ, it is possible to perform both insertion and deletion from one end, and DQ does not follow the LIFO principle. So the representation of the DQ is shown in the below image. So now let's come to the two types of DQ. So first is the input restricted DQ. As the name implies, an input restricted queue insertion operation can be performed at only one end, while deletion can be performed from both ends. Right? So like here you can see that insertion only occurs at one end, but delete here and here, the two operations can be performed at both the ends, that is front and rear. So this is known as an input restricted DQ. The second one is output restricted DQ, which means that the same thing will be applied, but here the insertion will be occur at both the ends, that is front and the rear, and the delete operation will occur only at the rear part. So let's see this line that as the name implies, in output restricted queue, deletion operation can be performed at only one end, while insertion can be performed from both ends. So now the operations performed on queue. So the fundamental operations that can be performed on the queue are enqueue. The enqueue operation is used to insert the element at the rear end of the queue. It returns void. The second one is dequeue. It performs the deletion from the front end of the queue. It also returns the element which has been removed from the front end. It returns an integer value. The third one is fill. This is the third operation that returns the element which is pointed by the front pointer in the queue but does not delete it. Then the queue overflow is full operation. So what does this operation do? It shows the overflow condition when the queue is completely full. And the final one is queue underflow. It means it is empty operation. It shows the underflow condition when the queue is empty, that is, no elements are in the queue. So now let's see the ways to implement the queue. So there are two ways of implementing the queue. First one is implementation using array. So the secretion allocation in a queue can be implemented using an array. And the second one is the implementation using linked list. The linked list allocation in a queue can be implemented using a linked list, as simple as that. Now that's all from my side. Today we have learned about the queue and the types of queue. So we will meet in the next lecture. Till then,